Today we're going to talk about full stack development platform. Actually, this is very close to what Sanjeev talked about this morning with the platform engineering. And what we want to do is talk about basically the journey you went through and how you've done it.
Sure. So I'll start back a few years, maybe about 5 years ago. We had bought into the automate everything. Everybody else buy into that as well? Automate everything, right? Yep. So we bought into the automate everything conversation, and we had promised our CIO 10% productivity because if we automate everything, everything should be faster, easier, better, right? We did that. We spent a lot of time. We celebrated. We high-fived each other. We spent a year saying we did it. We automated everything we could possibly automate. And by the time we got to the question that our CIO gave to us a year later, which, where's my productivity? We all kind of went, we don't know where that is, right? We had automated everything, great. But we had automated everything in a way that was about easing our pain, not driving a better delivery for the end product, which is what our business result should have been, right? So we had to take a step back. The step back we took was, what was our real problem statement? We took the focus on me. So our dev release process was automated. My data structure conversation and platform engineering was automated, but we did them in silos. We did them strictly focused inward, not focused as how do we make this so it's consumed by everybody else to really build that data platform. So what was the real problem statement? The problem statement really should have been, how do we get ourselves out of the business of infrastructure, of release and dev, so that way somebody else can run the whole thing from end to end. So we did basically what we call a BHAG, big, hairy, audacious goal. How do we do this in 3 years? And this was 5 years ago. So listen to Sanjeev talk this morning. I was like, we did that 4 years ago and went through that heavy learning cycle. We basically sat down and said, you know, we have to build a full stack platform, end to end. We have to do infrastructure as code, data as code, and release, obviously, as code, as part of a CI/CD pipeline that actually worked. At that point, it really wasn't out there yet. And it took us a while. We ran into some pretty big hurdles, but we got to a point where, as of today, actually as of 2 years ago now, actually, as we've matured it, we have a full development lifecycle for all of our pre-prod environments where nobody in my organization, nobody in our platform engineering organization touches a darn thing. We have a blue-green deployment cycle where everything is virtualized. We have 30 days, we stand up a core. That gets shut down and restarted and rebooted to a blue-green deployment cycle. So every 30 days, you have a fresh, brand new image. On top of each core, you have satellites. Those satellites basically are 2-week-old, that's as long as they can live, 2-week-old mini environments where we do thin clones using Delphix to actually incite developers to go build, develop, shut them down, commit your code, and that gets re-injected into the core.
So if the developers need something longer than 2 weeks, it just gets refreshed, or can they can't extend it?
They can't extend it. So what they do is they have to make sure, so we keep them in a cycle because our agile practices are 2-week cycles for agile practices, and we do daily deliveries or daily feeds from our GitHub. So theoretically, they should be able to spin it up in the morning, and this was the concept at least, spin it up in the morning, work all day with a fresh copy of the data, fresh copy of the applications they need, all the connectivity they would require, and then at the end of the day, commit it, spin it down, go home, come back the next day, spin it back up, and start all over again with the new train that they just committed.
Every engineer gets their own copy? Or every engineering group?
If you ask the developers, they each want their own.
Of course.
However, we're not made of money, and that means a lot of compute and resource and storage. So we limit it to basically at this point, every team, every development team can have 2 satellites. So right now we're running at about 140 satellites at any given point across a single core, while the other core is being refreshed and reimaged. We have plans to expand that to upwards of 500 satellites, but we're just working through what does that mean from a data perspective, what does that mean from a storage perspective, compute, and where's the ROI for that additional investment? Does it actually increase our productivity or not?
What was your biggest challenge in even getting to this point?
I would say the biggest challenge we had was our misconception that automating technology was going to answer everything. It does not answer everything. When we took a hard look at ourselves, we realized that if we just focus on the infrastructure, we focus on the technology stack, we're missing the business processes. Because what we really tried to do is take existing legacy business process and stick it over top of a fully CI/CD virtual platform, and they did not mesh. On top of that, we really didn't invest in any culture changes. So the culture of siloed execution was still there in a mentality perspective when we had just now merged everything into one releasable artifact. So between those two plus understanding that along with automating that pipeline, we have to do measurements and validation and so forth, we had to go back and really, that Venn diagram is all four of those key areas overlapping each other. It was not just a technology problem.
What caused you to go down this path to begin with? Obviously, you were looking for efficiency gains, but why was it decided that doing the platform was the way to go?
So our legacy environment deployment practice was very serial. You had your development environment, you moved from there into our integration environment, and then you go into your testing environment, then you go into your performance load environment, then you do your staging environment, and then you go to production. Right, so we had 6 environments, 5 or 6 depending on which application, and it was very serial. What we ran into is our application stack, Paychex has been around for 70 years. We have applications that are self-owned, we have applications that we've bought from other companies. There are so many entangled practices around data, around application design connectivity, that one person would throw a change into one environment and blow everything up for everybody else. And that was a run where we would have releases once every 3 months because we'd be unscrambling the spaghetti just to get to a point to actually release it.
How many of you run into that problem where you have these environments set up and one group does something and screws the entire environment for everyone else?
How many people
I'm expecting a lot more than the
7 years
3
ago?
hands.
How many people had that 7 years ago before you went to the cloud? Right. So that was one of our key things, is how do we break that apart? How do we solve that problem? And the problem was, how do we disconnect, how do we break apart, how do we make it so that one team can't impact everyone else? And the answer originally was automation. If we can automate everything, then you get rid of manual screw-ups, you get rid of everything else. Well, that just got us faster into trouble. It didn't actually solve the fact that we're creating troubles for ourselves.
Right.
Which is why we had to take a second look at it, which is why we came to the platform conversation.
Now, you've brought up data multiple times. So how big of a problem was data in order to do this?
It's still a problem, I would say. So the biggest problem with our data standpoint is that we have data sprawled all over the place. We have architecture designs or application architecture designs that are anything from your traditional monolith, where we have 4 or 5 different applications using a single database that's fairly large, to on the far end extreme, we have an application design that every client has its own database. So in that case, it's SQL Server. What that lends into is I have one database on one side that's 250 terabytes that somehow we have to clone, manage, mask, et cetera. And on the other hand, I've got 124,000 Azure SQL databases sitting in Azure that we also have to manage too. And then everything in between. So trying to create an automated solution, trying to create a platform strategy that addresses all the different types of application designs that we have within Paychex was one of the largest struggles we had. How do we get to a point where data virtualization, data masking, data consumption doesn't have to be custom for every type of data structure that lives in Paychex? Because that alone is a blocker. So, the reason why we mention data so much is that fundamentally, Paychex up to this point, up to about 2 or 3 years ago, our philosophy was very much that data was the byproduct of application design. We have changed that mentality with data. Now data is the gold asset and application is wrapped around how we manage the data. It's a fundamental shift in mindset because in the past, just throw it over in this database. Oh, we just create a couple tables, throw it in this database. So that's why we have a monolith of 8 different applications in a single database that we're slowly breaking apart. It's why in our world, reporting workloads versus operational workloads versus analytical workloads, we're all falling on the same data warehouse strategy, and we're separating those. So the data side of it is one of the key components of how do we mature our current platform framework into the future and eventually get to a production release cycle. Because right now it's purely focused in our non-prod environments.
So when you set up this platform for the engineers to use, and you're spinning up these environments. So now, because of Delphix, these environments that you're spinning up, they all get their virtual databases.
Yep.
And they're sharing the monolith terabyte database thing?
Yeah, so we actually have a process within 3 days. We take a copy of 180 terabyte database. We bring it down into our non-prods. We mask the whole thing through our normal analytic or masking algorithms, and then we make a gold copy, then turn around to place into the cores. We also make a thin clone copy of that same database. It's about 65 terabytes that we use to spin up in satellites as required.
Okay, and how do you make that thinner copy?
So we have some query structures that actually create from the gold copy image. We create a new image based off of a secondary clone. It's complicated and not great, but we're working on it. To be able to say now I've created a secondary gold image for the satellites. So basically, essentially, I've got my production 188 terabyte database. I make a copy to my non-prods. I then mask that in its current state. I make a gold copy for my core. I then take that gold copy, reinstate it, and then I make, depending on the application needs, I'll extract different levels of data sets from that master so that I know when application A needs a satellite, it uses gold copy 1B, if you will, or 1C.
Yeah.
So that way we can target which gold image targets which application stack. So when we spin up satellite, we know exactly, we can put both of them together and say, hey, dev team, here's your dedicated satellite. And you can do whatever you want. Break it, I don't care. Because if you break it, I'm just going to kill it and start it back over. But I know it's not going to impact my core. I know it's not going to impact every other development organization because they're the only one using that satellite.
Yep. Now, outside of the environment itself, what other things are part of this platform that the developers get?
So they inherit a couple different things with this platform. So obviously the data side, the application spin-up application side. We also, they inherit all the security protocols that are wrapped around our production data in the non-prod environment as well. So access controls, RBAC roles, et cetera, firewall port openings. We are just now getting to the point of opening up third-party integrations with off-site vendors. So production, we have some obviously integrations with various companies. We're starting to open that up as well as a dynamic creation, whereas in the past it's been a manual add-on. So the growth from where we are today is to really expand beyond just the core code concept and actually talk about all of our APIs, all of our integration strategies, and be able to spin those up dynamically on top of the underlying core.
So what about like the other tools, like their development tools, their testing tools, their other pieces? Is that all part of the platform, or is that completely separate? That's all part.
So they're all part of, so for example, we use XLR, XLD as part of our release strategy for our development teams. We actually spin up in the core our own instance that then inherits all the release cycles that come from our normal outside of the core concepts. Right? So that way, and then we can actually spin up XLD instances within each satellite. So a development team can go so far as developing, committing, and actually packaging within the satellite to confirm that it actually creates properly before they inject that back into the core image.
Great. Is there exceptions to the rule, or do they all have to use exactly what you give them?
So there are no exceptions in the sense of what we are providing. There's a very strict conversation that if your code base cannot support the spin up of satellites, you are not allowed into our environment. It's a bit of a protection to make sure that the framework stays solid. However, we do have what's called a shared services area. So we have a blue-green deployment where we spin up blue, we work on green, split it up, transfer everything over, spin down blue, work on that one. We actually have a third core that's static. That's for any system that can't be in those areas because they're not mature enough or they're just old that we haven't re-investigated, re-architected. So that if there's something that doesn't fit the model, we can stick it in the static core for now. It's just a temporary solution. So that way both cores still have access to some of the core applications if there's a connection between our payroll app for our, say, our taxation app, for example. It's a way to create an exceptional-like capability, but they still have to abide by our best practice when it comes to code commit, security, audit, governance, et cetera, before they get anywhere close to our framework. It's the only way for us to protect it, to keep it, the integrity of the system, and to actually keep it consumable and actually provide the benefit of increased productivity. What we don't want to do is just have a really fancy way of redoing what we just did, right? Where we get so messy, so complicated, with so many people in it, that we just reinvent a new way to have exactly the same problems.
Yeah.
And to do that, we have to hold some boundaries and some controls. I'm one of the people that control that entry point because I own all the data aspect of that conversation.
Yeah, what I have found with a lot of companies that are trying to do what you've done is so many of the business units or the development teams, they all want their own exceptions.
Yes.
And then all these groups, initially, I'm not saying you guys did it, but initially, oh yeah, we'll give you that exception, give you that exception, give you that exception. And then it's exactly what you said. What you built, the one thing you built, that's awesome, but now no one's really using that because you have so many exceptions, and now you're back to a complete mess.
Yep.
And people don't like to say no, right? You want to, like, I understand you're unique, and I get that you're different, and I understand, but by letting all the exceptions in, the whole thing just breaks down, and you're not achieving what you want to achieve.
We achieved that where we are today because we had to address the culture conversation.
Yeah.
The way that we addressed the culture conversation was by going up to our CIO and going, I need your stick. I need you to be the band hammer. I need you to be the one that says, no, you're going to do it the way they say it. Because before that, it was, come to us and we'll provide you the service. And it was supposed to be an open, happy, kumbaya, we're going to give you a great service, you're going to consume it, but that's exactly what happened. Well, I'm special. I just want this one exception. And then it turned to 2 exceptions, and turned to 3 exceptions, right? So what we had to make sure of is, as a culture, that we are okay with the concept of saying no. Or I should say, the art of saying no without actually saying no, right? How can we manage the expectations such that, I'd love to get you in, let's work on how do we get you up to our minimum requirements before I let you into my protected environment. Because that's the key, that's what's gonna drive productivity. What's not gonna drive productivity is what you mentioned, Steve, with all these exceptions and all these one-offs. Because that's just going to put us right back to where we were.
But what happens if they don't meet the minimum threshold to get into your framework to begin with? They're now not getting the benefit, and then your company's not getting the efficiencies they want.
Correct.
So somehow there's a stick in that, I'm sure.
There is. And the stick is they have to go in front of our CIO, explain what is it going to take for them to get there.
That is a stick.
They have to. That's what they have to do to get in front of it, is literally get in front of our CIO and explain why they can't change their model to adopt to our platform framework strategy. There is our stick.
I'm going to open it up to you guys. Do you guys have questions? All right.
Mike's coming around.
Perfect. When you merge the satellites back into Golden,
Yep, to the core.
okay, core, pardon me. What's the method that is it a schema compare?
So oddly enough, we don't actually merge anything. If the developers are working and they have code they want to commit, they go through our normal source controls and commits there. Once they're done, we kill it. Everything dies.
Okay.
Nothing comes back to infect the core.
Okay. And when are you ever overlaying, so do you have at all that progression, the linear progression that you were talking about was your old way?
The environment?
Yeah, so
Yep.
dev, QA,
Yep.
staging, I forget what you had there.
Yep, so staging, testing, performance load. We still have a couple. This core has replaced 3 of the 6 steps that we have, or 5 or 6 steps, depending on the application. It has not replaced all of them, mainly because our production environment and the step right below that, which is an identical mirror of production, there are some challenges. For example, in non-prods, I can make a copy of production as a golden image and replace. In production, that is the data. So it changes how I manage the data structure in the production environment, which also means I change how I do the load balanced or load performance environment. So we haven't solved that yet. We also have a situation. Go ahead.
The nature of my question there with the lower environments, do you still have them? If you ever overlay those, if they're VDBs and if
Yep.
they ever get refreshed, how do you refresh them while schema changes are on their way up? If they're not in prod yet and you're overlaying them with prod
Yep.
that don't have that schema change.
Yeah.
How do you guys manage that?
So one of the challenges we do is, and this is a cart before the horse conversation, right? So if I'm making changes in our non-prods and our prod doesn't have it yet, but you want it refreshed, that's why we keep it at 30 days, because our production or promote to production cycle is less than 30 days. So when I have my blue up, for example, and I'm making changes to a data schema, right? That's going through all the rest of the environments getting to production, but that blue has been based off of production instance from 30 days ago. So as long as that change in the data structure, or DDL, DML, whichever, is happening in our production environment before I start my green, I want to capture it and bring it back down to my green environment. It's actually one of the challenges of why we stick to 30 days. We'd like to actually make it faster, but I can't until I've solved my data problem on the production run.
So I know from earlier, one of the other issues you had was your developers are making their changes and they don't ever want it to get refreshed. Even if it's not a schema change, they have their own data in their VDBs that they've already set up, and that's what they're using to develop and test with, yet your overlay gets blown away.
Yep. If they had it. Test
Right.
data, for example, right?
But you're just basically saying every 2 weeks, we're gonna blow it away. So it's just a change in mentality.
Yeah.
Now, do the developers then write scripts or something? So say they have data sets they want, so every 2 weeks, then they have a script or something that reloads the data they want to put on that.
Yeah, so right now it's a static process, right? So for example, if I have a Mongo data set, we can reload that data that they count as testable data once we create the actual database. So we'll refresh from production, we'll inject our testable data. That's why earlier we're talking about the potential of using AI to create testable synthetic data. I'm super excited to see where that goes, because if I can do that by simply pointing it at my existing data set, hey, create me synthetic based off the data model, I can keep my development folks completely out of that conversation. And all I'm doing is turn around and saying, here's your testable data set, right? You know, testable data as a service conversation, right?
Okay,
There
there
you
we
go.
go.
Great.
Sean, I loved your opening comment or idea around, hey, we automated everything, yay for us, and then turned out productivity did not improve. Your CEO, I think you said his name was Mike. When you came to him and he brings you, hey, productivity hasn't improved. What metrics is he looking at to make that assertion, and like what is he using? What does he most care about in determining ROI?
So in this
What
case,
factors?
so in our case, it was how fast are we getting code to production?
Okay.
Has our release cycle increased or decreased, I should say, right? And has the quality increased? Because those are the three key areas that we kind of focused on as this should be the way that we improve our environment. And in all three metrics, we didn't hit anywhere near our targets. We weren't worse, let's put it. We were a little bit better, but not 10% better like we had planned. So was it a little faster? Yes, but not significantly. A good margin of error, right? Was quality better? A little bit, but not enough statistically to say it was because of the way we were doing things. And that's what really raised the questions.
And your KPIs or your metrics, as you say, were those aligned specifically to your team and your goals?
It was aligned to the PD and IT goals to support the business as far as product development, direction, and the market strategy, and what we're doing from a selling season year to year,
Got it.
right? As we release new feature sets, hey, did we hit all the feature sets we wanted to hit for this selling season? And when the answer is no, then anybody with a C starts asking questions.
Got it.
Right? Especially when the whole point of doing this effort, which took us 2 years to get there, was to increase our ability to deliver on time, and we didn't prove that out.
And then last thing, guys, unless anyone wants to ask another question, were you able to put a dollar value on that? Like, did he figure out the dollars of that versus, you know how a lot of times people, when they start throwing around time, people are like, that's so debatable, versus
Yep.
dollars is when people really start to take notice of things?
So we put rough numbers around it, and it's variable because ultimately Paychex has a certain revenue stream. Like we're 700,000 clients on our payroll app, we're $5 billion in revenue. We qualified it somewhere around 100 million of impact because of the features that we normally wouldn't get to, and because of the increased quality, increased availability. We actually saw a decrease in downtime for our applications above when we go to production, because everything had been vetted so well in the pre-prod, which we didn't see in the past. Now, we expect that if we can get to a promote to production where we use the same framework concept for our production releases, we should see another increase. How much? I don't know. We're working on that. But that's the next evolution of that conversation.
Very cool. Thank you.
One more.
All right.
Thank you. I have two questions. The first question is, you mentioned you actually have a SAP data set from your golden copy once it's masked. So since you use Delphix, what's the reason to have a subset of the data? Because Delphix just create a VDB, the size is pretty small.
So the way we approached it, again, we're a Delphix customer for 12 years, I think, at this point. We approached our separation of the data set by what application needed what data. And Delphix can absolutely make thin clone copies, it can make smaller subsets of the data set. We decided that we wanted to actually articulate and drive what data we picked and chose based off who was asking for that data set, which is a little bit more complex of a thing. Our first version was exactly what you said. We just did thin clone VDBs and said, okay, here's a sample of the data set.
Right.
And it didn't meet the needs. So when we started talking to our development partners, they said, if you could craft specifically which data I wanted from this larger data set, it would make me go way faster because then I wouldn't have to piecemeal it through. So we invested the time of figuring out a solution that says, I got my gold copy, it's been masked, go in and create a secondary VDB structure that tie it back to the satellites. It's just a way that we could invest it from the data side to help our dev partners. Ideally, I wouldn't want to do it that way, but in our current maturity, that was the best way to do it.
Okay, thank you. My second question is, when you mentioned that developers have their own copy, that's the data, right? So that's the database.
Yep.
So how you resolve the problems when the application is complicated that the database has to, for example, the application servers need to have a registration or have a configurations tied to that database names, which is quite unique. So how you resolve that
So
issue?
one of the tool sets that we use to stitch the framework together actually creates dynamic naming conventions for the DBs that are aligned to the satellite name. So the naming convention we use actually has the satellite name in the host name as well as the database name. So when you actually spin up the applications, it reads from a manifest that is dynamically created at the time of the satellite spin up. So that way, so when I look at all my VDBs that are out there that support this core, I can tell by simply the name which satellite those VDBs are assigned to, whether it's a part of the core or part of the satellite. And I know that I don't care what happens to that data if it's a satellite, I'm just going to destroy it anyways. But I care about what's going back into the core.
Right. Thank you.
You're welcome.
That's all the time we got. So thank you very much.
Welcome. Thank you guys for coming.
Thank you. That was very good.